guys, and welcome back to another tutorial where I walk you through the process of creating effective and crisp 3D elevation and built-up maps. We'll be using the global human settlement layer as an overlay to an elevation map, and then with the help of rayshader, we'll be turning this into an amazing 3D urban map. Welcome back to R, where we will first of all install and then load the packages that we need. I'm here going to create a list called libs. And then here I'm gonna name all the package names that we need. The first one is the tidyverse, which is the umbrella package for data wrangling and data visualization. In this tutorial, we'll be using it for data wrangling. The second one is the Terra package, which we will be using for loading and then working with raster files. The third one is GISCO-R, which we often use for getting the national boundaries in the simple features format. And in today's tutorial, we'll be also using GISCO-R for that purpose. Since we are working with simple features object, we definitely need to include here the SF package. And since we will be having here an elevation model turned into a 3D map, we need to get a digital elevation model. And for that purpose, we can be using elevator package. Now, we will also have an overlay of urban areas. And this one we would like to turn into an image and then load into R. In order to load into R as an image, we will need to use here a PNG package. We will also be adding labels of some of the most urbanized places. And for that purpose, we need to access the Geonames population data with coordinates for some of the biggest cities for every country. And to get the data itself, we will be using HTTR package to get a request to the website. Last but not least, we'll be using rayshader package to turn everything into a 3D map. All right, so once we have here a list of these libraries, we first of all need to check if they're already installed. So what I'm doing here is I'm taking this list of libs, and then I'm going to the row names of already installed packages. All right, so then if these are installed, we don't need to install them, but they are not, we need to install them. So in this case, we're going to write an if-else statement. So if any of these installed libraries are actually not installed, so if they equal false, then we need to open here curly brackets and we need to install packages. Now we don't need all the packages. We need those from that libs list that are not among the installed libraries. And then one of the last steps here is, of course, to install also the dependencies of our packages. Now that we installed everything, the very last step is to load these into R. And that is actually quite straightforward. What we need to do is we simply need to apply the library function to this list of libs. So the library function in R is used for loading packages into R. In today's tutorial, we'll be creating the elevation map of Austria overlaid with its urban areas. And for that purpose, we first of all need to get the shapefile of Austria. So here I'm going to create an object called country.sf. And then I'm going to be calling here GISCO-R and its function, which is called GISCO get countries. So here we need to specify, first of all, what is the country that we need. So you either specify ISO 2 or ISO 3 code. So for Austria, ISO 2 code is AT. And then in the second step, you also specify the resolution. So how crisp or detailed your shapefile is going to be. So here we go for the crispest resolution, which is 1. In today's tutorial, we're once again back at the Global Human Settlement Layer website. And this time we'll be using its built-up surface dataset, which shows us what is the extent of urban areas for different parts of the world. Like all other global human settlement datasets, such as, for example, the population dataset, this one too comes for different time periods. So we'll be using the one from 2020. One thing to note here is that the base dataset here is the 2018 one, and everything else is derived based on this one. So basically 2020, which we'll be using is the estimate. Now, because we want to use WGS84 coordinates reference system, we need to choose between 3 arc seconds or 30 arc seconds. So I'm going to go for 3 arc seconds. I know that this data set is bigger, but it's also crisper, and it's going to show us a much better picture than the one with 30 arc seconds. And then the coordinates reference system here is already set by default, so it's WGS84. Now, if you are interested about this data set, I would encourage you to click here on this GHSL data package 2023 report link, and then read about the specific datasets, which is called GHS_build_S. Now, in our case, what we want to download here is we want to do the global download. So we'll be downloading the entire dataset for the whole world and then cropping only for the country that we need. Before we do that, we need to decide whether we want to use both the residential and non-residential classification or just non-residential. Now, in short, the difference between these two is that the first one, so the total residential and non-residential, gives you information about the area, total size of the urban area, while this second one, which we'll be using, shows you the fractional cover. So what is the percentage of the pixel of the area that is under the urban area? Essentially, in our case, it's not going to make much more difference whether we're going to be using one or the other, because anyways, we'll be filtering only those that have some kind of a built-up area, so that are higher than 0. But in this case, perhaps it's going to be more straightforward. In anyways, it is a smaller data set. So once we choose this non-residential option, we go down here to this global download, and then because I would like to download this one within R, I simply click here using the right click of the mouse and then copy link address. And then we will go back to R, where we will initiate a download of this file to our main working directory. Over here, I pasted the link to the global built-up file, and as you can see, it's a zip file. So the next thing we will do here is declare this as our URL and put the double quotation marks around this link. The next thing is we will grab the file name from this URL using base name function from base R, and then we can proceed with downloading this using download file function from base R. So over here, we need to first of all declare our URL, which is declared already as URL. Then we need to define the destination file name, which is actually this file name that we already grabbed. And then finally, we need to define here the modes of download, which is going to be the binary mode. Once we download this, we need to unzip this file. And for unzipping, we can simply pass file name to this base R unzip function. Now, one thing you will notice while enlisting the files that you just unzipped is that there is going to be a folder under this name, and then under this folder, under the same name but with a TIFF extension, will be our raster file. Now, our next step is to load this raster file into R, and for that purpose, we'll be using Terra Rust function, which is used for loading files. Now, because this is a pathway to our raster file, we need to put double quotation marks around it. Of course, close these brackets and then name this object. And we're going to name it country built up, and then assign this to it. And now this is going to load the global raster cover, but what we want here is we want a built-up cover only for the extent of the Austrian border. So we'll need to clip this one. And for clipping, we can again call to rescue Terra crop function. So within this one, what we need to do is we need to provide this country SF object. So these are the Austrian national boundaries in the simple features format. And then we need to coerce this into Terra vector format in order to use it within this Terra crop function. Then the second one is that we want to actually take everything that is inside of the boundary. So that's why I'm putting this next argument. And the final argument is to declare everything outside the national boundaries as missing values, that is excluded. All right, now that we have this, we can plot and see whether we really got the raster file for Austria. And we can use, again, Terra and this time plots for this purpose. And we simply pass here this country built up that we created. And once you run this whole chunk, you should be able to see the country built up raster only for the borders of Austria. In this section, we will be fetching the digital elevation model, and then we'll be using it to resample our built up layer in order for both layers to fit once we get to the rayshader part. So the first thing we will do here is create an object called ele, and then we can use elevator package, and from elevator we can use get ele raster, which is going to help us get the digital elevation model. Now, because we want only the digital elevation model for Austria and the borders of Austria. Here in locations, we can simply pass country SF. Then we can choose the zoom here. Now, because Austria is relatively small in terms of its territory, we're going to be going for a bit higher zoom of 9. But if your country is larger than Austria, then maybe you should consider decreasing the zoom here. And then finally, as I said, because I would like a digital elevation model only for the Austria, then here we simply pass locations argument to the clip. All right, once we get this elevation raster, we can go ahead and use it to resample our built-up raster. So we'll create here an object called country built-up resampled, and then we'll be using from Terra this option resample. And then to resample, we need to pass 3 arguments. The first one is what we want to resample. So we want to resample the country build-up object. The second one is what we're going to be using to resample. So we'll be using this elef object, but because it's not in a Terra Rust format, we simply need here to coerce it into a Terra Rust format. And then the third argument here is the method of resampling. So the method here we will be using is the mirror method, which is used for preserving the categorical values in our data. Okay, so once we actually have this, we can go ahead and change then the values. So what we're interested in here is keeping only those values that have certain built-up areas. So everything that equals 0, we will simply declare as an NA value. So the first thing before we actually jump into this is to declare the coordinates reference system that we'll be using. So we're not going to be using the standard WGS84 because Austria is a European country. We'll be using the Lambert projection, which I just pasted here. If your country is not a European country, you can simply omit this part. You don't need to turn it into this projection. If it is, I strongly encourage you to use this. So let's then declare this as CRS Lambert, and let's put double quotations marks around this so that it can be used in R. And now in this part, we'll be using this country built-up resampled and changing the values. And this is how we're going to be doing that. In Terra, there is a function, a very convenient one, which is called if-else, where you can actually change the values of your raster. So what we want to do here is we can actually create a new one, which is called country built-up, for example, single. And then here we can pass what we want to change. So we want to change this country built-up resampled in this following way. So if it's greater than 0, so if there is any kind of a fractional built-up cover area, we're going to define it as 1. Otherwise, if it equals 0, because values here cannot be negative, it's from 0 to 100. Well, in this case, if it equals to 0, then we simply return the value of 0. And then the last step that we will do here is to reproject this raster file into this CRS Lambert projection. Again, if you're using a non-European country, you can skip this last line. Once we resampled our built-up raster and we also changed the raster values only to 0 and 1, in the last step, we also want to adjust or actually set the color for our values. So here we actually will just substitute the existing values. And the first thing we will need to do here is define the colors. So for the colors, I will be using here a red color to denote the built-up or these urban areas. And this is something that is usually used in some other land cover datasets. So that's the first one. Here I'm going to define the colors, and the second one is the value for which we want to define this color. And here we will call this from. Well, we want everything to be red that already has actually a value of 1. Everything that has 0 should not have any color. And then the final one here, argument is 2. So this is basically what we want to turn this 1 into. We want to turn this, everything that has the value 1 should have also the color, this color here. So the way we do that is, as we did as one of the previous tutorials, is use here call to RGB, basically turning this hexagonal value into the RGB value, red, green, blue in other words. And here we simply need to pass calls. So once we do that, the next step is to get rid of any missing values, even though we should not have, but we need to actually do that in order to have only two values, so 0 and 1. And this is what we are doing here. And then the final step is to use all these objects to substitute the values of our country built-up raster. So over here, I'm going to create a new object called country built-up call. And then I'm going to use here from Terra a function subst, which we used in some of the previous tutorials for substituting the values, the color values of our raster file. So over here, we need to pass, first of all, the raster file itself. So that one is country built up single. The second one is from values. We already created the from object. Then two values, also we created two object. And finally, for the names, we'll be using the list of colors. Because rayshader works with image files as overlays, we need to save this raster file as an image file or a PNG file. So let's first of all define the name of this file. It's going to be called image file. And let's, for example, call this Austria built up.png. So .png here is very important. And then in the last step, we simply save this using Terra write raster. And we also did in one of the previous tutorials. So here we simply pass this country built up call. And then in the second step, we pass the name of the image file. We also need to here define the flag for the NA values. In our case, we want to turn everything that equals 0, so the lack of built-up areas, we want to turn that into missing values. In other words, this should not have a color. So we're going to simply here define 0. And then finally, this is an optional one, whether you want to overwrite maybe the existing file under the same name so that it equals true. Okay, so this is going to save that raster file as a PNG file in our working directory. And then we need to now load it back into R as an image file. So we can just call here image. And this is where we use PNG and read PNG. And we simply need to pass here image file in order to read this PNG file. We now have the overlay image. Our next step is to convert the digital elevation model into a matrix because a rayshader works with matrices. And that is going to be pretty straightforward. But before we do that, we need to coerce this elef object into a Terra Rust object. And then I'm also going to reproject it, which you can skip if you're not working with a European country. And in the final step, I will just simply transform everything into a matrix. So here we go. I'm going to call this object elef Lambert because it's a Lambert projection. And then here, elef, I'm going to pass into a pipe. And then I'm going to coerce it into a Terra Rust object. Now, here's the part where I'm going to reproject. Again, if you're using a non-European country as an example, you can just skip this following line that I will write. If you're going for reproducing this or creating a map of another European country, then you can go ahead and write this one, which is Terra project. And then within the brackets, we simply pass CRS Lambert. Okay, so now we have the reprojected, also Terra spatial raster file object. And then in the last part, we create this elevation matrix with a shorthand LMAT. And using rayshader, a raster to matrix, we pass this elef Lambert, which is going to create a matrix for us. In this tutorial, I want to show you how you can add city names to your map and make it more informative for your audience. So we'll be getting the coordinates for Austrian cities using Geonames dataset, which we used in one of the first tutorials that I created. But in this one, instead of going for all the population over 1,000, we're just going to be going for a bit higher, which is 5,000, because anyways, in our map, we'll be showing just a few cities. So this is the link that we're using. I'm also going to put this into the description box of this video. But for now, this is the link to the dataset. And here we need to define this, of course, link. But before we do that, let's first of all define the file name for our table that we'll be downloading. And I'm just going to call this one, for example, Geonames and then dash population. And then this one is actually in the CSV format. So I also need to put here that it's a CSV. All right, then we can actually write a function which is gonna download the data for us. So I'm gonna call this one simply get geonames data, and I'm gonna declare it as a function and then open here curly brackets. So the first thing we need to do is define here the table link, and the table link is right here. I just pasted it from the website. And we need to put double quotation marks around it. So that's the first thing we need to. Now comes into effect the HTTR package from which we'll be using the GET request in order to get the data from this link. So I'm going to call this res, and then I'm going to be using here HTTR and then GET function from HTTR. So over here we need to pass this table link. That's the first one. So basically the URL which we'll be using. The second one is a function or attribute from HTTR, which is called write disk. Basically, this is going to write to our local disk. And this actually here, you need to specify what is the file name that you're going to write. So simply here, we pass file name that we previously defined outside of the function. And then here, there is one optional function, which can actually show you the progress of downloading, and I like to include it. It's simply called progress function from HTTR, so you can just declare it like here. In order to activate this whole thing, we simply need to then call this get geonames data function like this. All right, so this is going to download a very small file to your local disk, so only several megabytes. So our next step will be to actually load this table into R. So for that purpose, we can actually write here a new function, which is going to be called load geonames data. We again declare it as a function, open here curly brackets, and within this one, we need to use read CSV from base R to read this CSV file. And I'm going to call this places_df. So this is going to load places for the entire globe. Again, it's a very small file, so it's not going to actually hurt your performance or anything. So here we use read CSV, and then again we pass here this file name, which we actually define outside the function. So that's why we can reuse it once more. And then for the separator, as we used in that previous tutorial, we need to use a semicolon here. Okay, and then the very last step is to return this object called placesdf, which we're gonna do just here. And then finally, in order to create this CSV file, we simply need to, again, create this placesdf object and then call here this load geonames data function. All right, once we do that, we can quickly inspect this data frame. So we can, for example, inspect a few first rows using this head function. What I'm just gonna do is I'm gonna just pull this up so that you can see like this, and then we can use the first few rows. So you can see here there are actually a lot of columns, and we don't need all of them. So what we actually need here is we definitely need column number 2, which is the town name. There's also SKI name or SC name here, which is actually without any local letters or symbols. We also need here the country codes. So that is this one. And then in terms of the coordinates, we need here location. And we also need population, because I would like to take only the 3 largest city names here. So the location here is, if you can see, it's simply a column that puts together longitude and latitude. So we will need actually to split this one into coordinates, longitude and latitude separate. All right, let's actually do that in the next step. So the next step will be to, first of all, choose only those columns that we need, as I said, and then let's just rename them into something that is more appropriate for us. So I'm going to call this one, this new object, I'm just going to call it places modified df. And here I'm going to call places df. And then in order to select these that we need, we can just simply open this brackets here and then declare all those that we need. So as we said, we need a city name, which is 2. Then we definitely need the country name, the ISO to code, so that we can filter out only Austria. We also need the population because I would like to take only the top 3 cities. And finally, we need this last column, which is the coordinates themselves. And then we can go ahead and rename these this new object or its columns, and take something that makes more sense for us. So we can, for example, here go for the name. That's going to be the first one, signifying the name of the cities. The second one can be the country codes. Then the third one is the population, and we can just simply use here shorthand, just pop. And then the final one is going to be the coords. Okay, so once we have this, our next step will be to split this coords column into longitude and latitude. And that is quite easy because we can use string R from tidyverse package and its function, which is going to be splitting this. So here what we can do is we don't need to create a new object. We can simply go here for places modified df. And then over here, what we need to do is declare what are the columns that we're going to be creating. So we're going to be creating two columns. Now, it's very important to pay attention here. So this coords column that consists of latitude and longitude has latitude first and longitude second. So this is what we also need to define here. And then once we define here, we can then use string R for splitting this. So for splitting, we need to use from string R. There is a function called str split fixed. All right. And then within this one, we simply need to say that we're going to be using from places modified df. We'll be using that coords column, which consists of those two. That's the first one. The second one is what is the symbol that we will be using for splitting. So if you remember, the latitude and longitude are divided by a comma. So here we simply define that it's a comma. And then the final argument is how many new columns are we going to be creating, which is 2. So one is for latitude and the other one for longitude. Because rayshader will accept either SF objects or vectors, we will need to transform now this newly created data frame into an SF object. So we're going to call this places clean SF, clean because we will finally have all the columns in the appropriate format that we need. And then here we can place this places modified df into a pipe and then do our first step. And our first step will be to filter out everything that is not in Austria. So we can use the dplyr from tidyverse and then its function called filter. So here we can use country codes, which we previously defined as a column, and here only use those that use ISO to code at 80, which is basically ISO to code for Austria. The next step that we can do is make our dataset smaller, and as I said, take only top 3 cities based on the population. Now that's quite easy if you use slice max from dplyr. Basically what this is going to do for you is you first of all declare here the column that you will be using, and then it's going to take the 3 maximum or the 3 largest values based on this column. If you say here n equals 3, you can of course increase here or decrease the number of values depending how many towns you would like to see on the map. Okay, now in the next step, what we can do is select only those columns that we need. Well, first of all, we don't need coords, so that's why I'm putting here minus in front of it. We don't need any more the country codes because we already took all the Austrian cities we need. And finally, we don't need here the population, so I'm also getting rid of the population. All right, now that we have a clean data frame, we can finally transform it into an SF object. So to transform it, we use st as SF from the SF package. And then here we define the coordinate names. So longitude is long from the data frame and lat is for latitude. And then the very last step here is to declare the coordinates reference system because R otherwise is not going to know. And this one is the WGS84 coordinates reference system. But if you remember, our raster files are in the Lambert projection. And if you're also using Lambert projection, we need to now transform it. If you're not, you can simply skip this part. So for that purpose, we'll be using st transform from the SF package. And then here for the CRS, we'll be defining CRS Lamberts. When you're adding labels to a 3D plot using rayshader, you need to take care of the altitude. So you want to make sure that your labels are visible on the map. In other words, they should be above the highest peak on the map. So in this part, I'm going to show you a small trick, how you can get the maximum altitude. And then within the code for generating the rayshader plot, I will show you how you can add some more value to it so that you really make sure that your labels are visible even in the areas with the highest mountain. So here I'm going to create an object called max altitude. And then I'm going to here take the maximum value of Terra values and Terra values of our LF Lamberts. So that's also very important. That's the one that we transform into a Lambert project. And then here also very important thing is removing all, the missing values. Okay, so once you actually run this, we can just quickly, check what is the max altitude. So the max altitude here will be over 7,000 meters. So that's the highest peak. And with this information, we can now pass this max altitude to our rayshader code and then add some more values just to make sure that the labels will be visible on our map. All right, it's time to render our scene. And before we do that, let's first of all define our width and the height of our scene. And the best way to do that is simply grab the width and the height of your raster file, which anyways will be used here as to build your scene. So I'm going to define height as h, and this one is going to be based on the number of rows of our LF Lambert raster. And then for the width, it's going to be based on the number of columns of also our LF Lambert. Okay, now that we have this, we can now take each of those elements that we previously created and pass it into our code and create a 3D scene. We start off by first of all defining the elevation matrix. So we put that one into a pipe and then we add things. The first one we want to define here is the height shade of our elevation and also the texture we'll be using. So here we'll be using height shade from rayshader, and then defining the texture just as we also did in one of the previous tutorials on creating a 3D earthquake map. So we'll be using the same methods and we'll be using more or less the same colors. So over here I'm using color ramp palette from base R because I want to actually create a texture of multiple colors. So I would like to have two colors. One is going to be gray and the other one is going to be more towards the white. So the one that I'm going to be using as a white color, this gray 90, this one will be used to represent valleys and plains. And then as the elevation increases, I would like this to become more gray. And that's why I'm using here gray 40. Okay, and then the last step here is you can create more values of this. For example, I here put number of 128 if you want to actually have more kind of a shades in your map. Okay, so this was the first step. The second step is to then add this image overlay that we created. So for that purpose, here I'm using from rayshader this add overlay function. And then here I'm passing this image. And then the second thing I'm passing, which is very important, is the alpha layer. So this is how much this is going to be visible. If you put 0, it's going to be completely transparent, so invisible. But if you put 1, it's going to be completely visible in those parts of the high shade that is created. So I want this image to be of built-up areas completely visible. Now that we have this, we can go ahead and add another overlay, and this is where the labels kick in. So the first part is the same as in the previous one, so we are basically adding an overlay, but then we are using another function here from rayshader, which is called generate a label overlay. So over here, we need to define several things. The first one is this SF object that we previously created, which stores the names of our towns. So it's called places claim SF. That's the first one. Then we need to define the extent of our scene where this is going to take place. Well, for this one, you simply need to define this raster file that we're already using. Then in the second step or the third step, you need to define here the text size. So these are pixels, and this is a bit of a hit and miss, so I think you should really definitely try this in your own case and see what works for you, whether a lower or a higher text size value. Now for the color, I was thinking about something that would, be somewhat of a contrast to that a red brick color for the build-up areas. And I decided to go here for the navy blue color. So this is actually the hex code for the navy blue value. Now, I would like also these labels to be visible, and for that purpose, I want to add a bit of a blur effect to the background around them. So basically blur everything around them, but keep a focus on the label itself and present the label itself. And there is a very convenient function here within this one. It's called halo color. So this halo color will actually do exactly that. It's going to add you color and a bit of a blurry effect around it so that actually our eyes can see the labels well. So for the halo color, I'm actually going to go for this gray 90, which we already used previously for the height shade as the value for the planes. All right. Then you can also define some other things related to this halo, and one of them is expand. So this is how much actually this area around your text is going to be big. And here I actually go for 8 also. Here again, it's something that you definitely need to try based on your use case. You can also here define how strong this blur effect is going to be. And basically here you should not go for values that are higher than 30, because otherwise it's not gonna, you won't see any effect. Basically it defaults to this one. So here I went for like 10, but again, this is totally up to you and your preferences whether you want to blur it more or less. And the final thing related to halo is how much transparent it's going to be. Since I don't want to make it completely transparent, I actually want to make it very visible. I'm going to go for the value 0.8. So 0 is basically this effect is completely invisible, and 1 it's completely visible, so completely blurs everything in the background. I want to give a bit also space to the background itself. And then the last 2 steps is to define the height map. So the height map is definitely this elevation matrix. And the last but not least is what is the data label column that we're going to be using. And that one is simply called name. All right, now that we define the height shade, we define the first overlay and also this label overlay, the last step is to write the code that will generate our 3D plot. So we'll be using from rayshader a function which is called plot3d. And then here we need to pass several mandatory things. The first one is the elevation matrix. The second one is how much this terrain is going to be ragged. So how much spikes are going to have. Now, Austria is a pretty mountainous country. So here you want actually to increase your Z scale value so that it's not too ragged. If you decrease it, where 1 is the minimum value, it might become too ragged. So I'm here going to go for the value of, for example, 10. But in some cases, you might even want to increase this value. All right. There are several other things that I like to do. One of them is to turn off the solids plane plane around the map itself. Then I definitely want to have the shadows in this tutorial because we'll be using a light scene. Then you can also define here how strong the shadow in the background is going to be. I'm going to make it super weak here. You can also define the background color of your plots. We can go for white, but eventually I do want to make it a bit darker. So there is a nice contrast between a pretty light map and a darker background. And here you can also define the window size. Now the window size, you remember we already defined the height and width, so we can just pass it here. But because window size is in pixels, this is going to be too much, So we should here divide by a certain value, let's say for example 8, and this is going to give us a bit smaller window size. There are other things that you can define also, for example zoom. Zoom goes from 0 to 1, where 0 is actually completely something zoomed in, and 1 is completely zoomed out. So here I'm going to go for something in the middle, and also I'm going to go for 85 degrees angle, and I'm not actually going to tilt the map. All right, so once you actually run this very long code, you should be able to see the scene with both the Austrian urban areas, the elevation, and also labels. Now, if you're not happy with the outlook of your window, if you want to expand it, so if it doesn't capture the entire map of your country, then you can use from rayshader something which is called render camera. So over here, you can actually redefine these last three values. So you can either increase or decrease your zoom, and also you can change this degree value and also the tiltedness. In this tutorial, once again, we'll be using a custom light, which I found on the Polyhaven website. And this is actually the link to the specific HDR lights scene that I will be using. It's called Photo Studio Love Hole. This is a source of a warm light, and it's really perfect for our scene and given the colors of our urban areas and also labels. So here, what we're going to do, first of all, is to download to this file to our local drive. So I'm going to do basically the same thing as I did at the very beginning when we were downloading that raster file. But with one exception here, we already have it in the format we need. You can see the HDR extension in the link. So here I'm going to call this HDRI file. And I'm simply going to grab here the name of the file from this link. And then once more, I will be using here download file. For the URL, we're going to pass in here EU. And for the destination file, we will be passing here this HDRI file name. And then finally, for the mode, we'll be using here the binary mode. So WE. Okay, and now we can proceed with rendering the object itself. The first thing is, of course, to call a rayshader, a render high quality. And then over here, we need to define actually the file name. So we can, for example, call it 3D builds up Austria.png. So this is also very important. In the second step, there are some things that are optional. One of them is, for example, that to enable the preview of the rendering scene. The third one is to define that there is going to be the light in the scene. And then because we're using this customized light file, we also need to define that here. So this is going to be called environment_light. So rayshader also allows for that possibility that you include these ones. And then we simply copy and paste this HDRI file name that we previously downloaded. One also cool stuff about rayshader is that once you're using this customized light files, you can also define here the intensity of those. So you can actually increase or decrease. And the one here is kind of the baseline value. If you want to increase, you add a bit more. If you want to decrease, you go below 1. So I'm going to here increase by 25%. So I'm just going to add, put here 1.25. And then, as I said before, I would like the background of this plot to be a bit darker. So there is a nice contrast between a dark background and a bit of a light map itself. And for that purpose, we can use the ground material argument here, and then we can call ray render, which is one of the dependencies of the rayshader, and it has a very cool function which is called diffuse. So here we can select the color that we want to diffuse, and here I can go for example, charcoal gray color. All right, so you remember that we also have labels in our plot, and this is the place where you can customize the size of your label. For that, you can use text_size. And here I'm going to go for 90 pixels because our plot, our map is going to be quite big. It's going to be, I think, 3K times 5K. So 90 pixels is not going to be that much. But again, this is something to play with and decide on your own. One thing that I like to turn off is the interactive mode where you can actually move the scene while it renders. And then the last two things that I want to define here is the width. So for the width of our object, I'm just going to use W, and then for the height, I'm going to use H. And this is how you create effective and crisp 3D elevation and built-up maps with a rayshader in R. I'm really curious, guys, how you take this tutorial on a journey across the world and create your own awesome country and a regional 3D elevation and built-up maps. If, however, you're interested in replicating today's analysis, I prepared a link to the GitHub repo in the description box below, so do check it out. Feel free to clone it, reuse it, modify it as you see fit. If you have any questions or comments, feel free to reach out to me here on YouTube, but also on X and Instagram. If you're new to R and you seek to expand your data visualization and geospatial knowledge in R, I prepared a few cool tutorials for you, so do check them out. See you next time.